Hello, my name is Babak, and I will talk about a gas flaring reduction method. And as you're well aware, in oil and gas process plants, if there is an overpressure of gas during abnormal process condition, it has to be depressurized, and flaring network is used for that purpose. Well, based on hazard studies and for safety purposes, the flare stack design will always be retained in terms of its size. It has to be able to depressurize the governing case or worst case analysis for the excess gas that's developed in abnormal process conditions. But there are ways that we can reduce gas flaring, and well, one way is to lower the frequency of abnormal conditions that lead to the buildup of excess gas and the need for depressurization. That's one way, and a lot of work has been done for that purpose. And another way is to predict the time period or when there will be a excess gas buildup that requires depressurization, and to reroute the excess gas instead of burning it in the flare stack. Well, how is that possible? Well, with the help of the sensors and the design of the plant and previous cases of abnormal process condition and other data which are available from many other plants which can be correlated, basically using big data and also artificial intelligence and edge computing with the help of a low latency network like 5G or 6G. It is possible to predict when there will be a abnormal process condition that could lead to excess gas that requires depressurization. So, if it's possible to detect uh, this uh, this type of event, then the excess gas can be depressurized, but instead of going through the flare stack to be burned, it could be redirected to on-site or off-site facilities where it could be used as is to feed another plant, or if it could be used as an inlet for generating electricity in electrical generators, or maybe it could basically we could just convert it into valuable products. Now, it is not always possible to redirect all of the gas, excess gas, to other facilities. Maybe a portion of the excess gas can be redirected, but the remaining portion will then have to be flared. And this is okay because we have the aim is to reduce the amount of flaring, and this is one way to achieve it. Now, if the excess gas that's depressurized and redirected to a generator, uh, it will definitely produce electricity, and if the electricity is not needed by all the local facilities, then it can go into the grid electrical network and be used elsewhere. Now, in the electrical generator facilities, if you use this extra gas as a source to produce electricity, there will be CO2 produced, and the CO2 that's produced in that on-site or off-site electric generator facility, that can be either combined with some of the excess gas, or by itself, or just by itself it can be converted into valuable products. So technology is available to take the a portion of the gas that goes into the electrical generator and combine it with the like CO2 that's emitted by the generator, and the combined gases. There's technology to convert that into valuable product, or another option is to have all the excess gas go into the electrical generators and have the just the CO2 emission, and the CO2 emission can be converted by itself. But since there will be a lot of combination of gases, maybe it's more feasible to mix some of the excess gases and also the CO2 that's emitted from the gas electrical generator to convert them into valuable products. But no matter what, the point is to have a clean environment. So when we redirect the excess gas from the main primary plant, the aim is to not have it be flared, and it's for environmental purposes. Now, when the gas is redirected to another place, we also have to make sure that that if that gas is being used for any purpose, if it's going to be converted into electricity or whatever, that we take care of the emissions at that point too. And again, there's always a need for this extra electricity from the generators that can be used to drive electrically driven equipment, or to generate hydrogen fuel or elsewhere, wherever, after it goes through the grid system. So the electricity can be used somewhere else for whatever purpose. So this is so again, we have two methods that I know of. There might be other methods too that you can take care of. You can reduce the gas flaring. One method is to come up with designs or make sure that the equipments are tested and are operating correctly. The connections are perfect as much as possible, and there are planned shutdowns, and also again, advanced control systems can be used to ensure that the frequency of abnormal process conditions that lead to depressurization would be reduced. That's one way. So basically, one method is to reduce the abnormal process condition that leads to excess gas, which then would require depressurization. And another method is a complementary method, by the way, is to let the excess gas be depressurized, but instead of directing it to the flare stack, redirect them as much as possible to other facilities where they can be converted into electricity or other forms, or it can be used elsewhere. Well, thank you for listening to my presentation.